As with any other topic, NAT also gets easier with practice. The more examples you see, the better you'll understand it. In this lesson, we'll do one example in which we will cover both NAT and PAT. What is NAT and what do we use it for? You're probably already aware that there's not enough IP addresses for all of us to use the internet, at least not in the way we use it today. So NAT was one of the solutions proposed to combat this issue. Basically, the idea behind it is to have one or few public IPs and use those public IPs when out on the internet, but internally you'd actually be using private IPs. That way you save the already non-existent public IP addresses. Let's look at an example. I stole this from my other course, IP Addressing Zero to Hero. If you want a coupon for that, let me know. I'll be happy to send it to you. Anyway, what we have here is a LAN over here with obviously private IPs, and then a web server, which of course has to have a public IP. This interface on the left, which is a gateway for the local area network, has a private IP address 192.168.1.1, and the interface on the right has a public address 76.0.13.6. If this PC right here sends a packet to the web server, let's say it requests a web page, this is what source and destination addresses will be. Source is the private IP of the laptop and destination is the IP of the web server. Next, this packet gets to the switch and the parameters stay the same. And then they're still the same on the router's inbound interface. But as we get to the router's outbound interface, the source IP changes from the sender's laptop's private IP to this router's public IP address. Next, our packet continues its journey all the way to the web server with those same IPs. And then, once the web server returns the packet back, source IP is now the web server's IP, and the destination is the NAT translated public IP of our router. Now, pay attention to the destination IP. On the outside interface of the router, destination IP is still the public IP. Once the packet goes through the router, as the router remembered that it switched this packet's private IP for a public internet routable IP, it will now reverse that, and from that moment on, as the packet enters the local area network where we have private addressing, we will use the sender PC's private IP address. Now, if you're wondering what would happen if any of the other two laptops sent a packet to the web server, the answer is it depends. There are different types of NAT. There's the static NAT, in which case, in our example, every PC would get its own public IP, meaning you wouldn't save any public IPs, rather you'd have a public IP for each private IP in the LAN. This is useful when you have servers that should be publicly accessible, but they're inside a local area network with private addressing. In that case, you will practically have a simple translation table on your router or firewall wherever you're doing the NAT. So you will have a table which will list which private IP translates to which public IP. Yes, it's that simple. Anytime a host from the LAN sends a packet out to the internet, the router will just look at the table and switch its private IP to the appropriate public IP. Once the packet returns, it will do the opposite. With dynamic NAT, however, we map multiple and potentially lots of private IPs into a single public IP. By doing this, we save the public IP addresses, and that's a good thing, but there's also a disadvantage when doing this, and that is you lose accountability. For example, if many users get the same public IP and one of them does something malicious, you'll have a very hard time tracking that one user, since when looking from the outside, they're all represented by a single public IP address. Actually, dynamic NAT doesn't necessarily mean you'll translate all of your private addresses into only one public address. You can also have a pool of private ones and translate them into a pool of public IPs. For example, picture an internet service provider. They know that there will never be a time when all of their customers are requiring a public IP at the same time. This is a fact. So what they do is they have more customers than they have public IPs. Their pool of customers is bigger than the pool of available public addresses, but since they know that there will never be a time when all of them need a public IP at the same time, they can absolutely get away with this. Anyway, the dynamic NAT option that is most often used is this PAT option. PAT stands for Port Address Translation, and this is how it works. Just a disclaimer here, I'm going to use totally random port numbers here and use the same topology as before. Only this time we'll look at port numbers being sent in those packets as well. So we don't only have the source IP and the destination IP, we also consider source port number and destination port number. Let's look at this packet going from the third laptop to web server. Source port is 50,001, again, totally random numbers, and destination port is 80. When the packet gets to the router, which has NAT configured, that is when the router actually maps the private IP and its source port to this single public IP all other hosts from this LAN will use. Since many computers need to use the same public IP, the router needs something to distinguish those PCs from one another. That something is going to be this new port number, 10,001. Again, I picked this number completely randomly. If you're wondering what happens when a different PC sends a packet and needs to use that very same public IP, this is it. This time the source port is 60,001. When that packet reaches our NAT router, it will get its own mapping with its own port. Once these packets come back from the server, the destination ports will be 10,001 and 10,002. The NAT router will look into its translation table and see that it used this 10,001 port for private IP 192.168.1.5 and the other one 10,002 for 192.168.1.3. That's how it will know who to forward the packet to. Now, how do we configure NAT? Static NAT is pretty straightforward, since all you want to do there is give each private IP its own public IP. So you simply create a mapping for each of your private IPs manually. The command isn't very intuitive, unfortunately, but here's what these words mean. IPNAT obviously means that you want to configure NAT, and then inside source tells the router that you will list the private or the inside IP first, and you'll see later that a part of NAT configuration is also designating an inside and an outside interface, so that the interfaces which receive and send the packets on the router, actually know that they're supposed to do NAT, so that once they receive a packet and they see a source or destination IP address, they actually have to do something extra. They have to look into this NAT translation table. The first IP is the private inside IP, and the second one is the public one that the private IP gets translated to. With dynamic NAT, it's a bit more tricky because you need to specify a range or a pool of addresses you want to use on both sides. If you want to use typical PAT, where you have several private or many private IPs, but only one public IP, in that case, you will say to the router, here's a pool of private IPs I want translated into this single public IP. There are two ways to create this pool. First is an ACL, and second is an actual pool, similar to what we've created for DHCP pools earlier. But access lists are more commonly used and are, in my opinion, simpler. So let's go with access lists. We're going to create this standard access list because all we need is some way to specify a range of addresses, and a standard access list accomplishes that perfectly. In this case, we have specified a range of addresses from 192.168.1.0 to 192.168.1.255. What do we do with that ACL? We use it in our NAT command. If you can remember, we used this first part of this command in the static NAT configuration as well, IP NAT inside source. And then, unlike in that command where we only listed one static IP, here we are listing an entire range of IPs to be translated into a single public IP. The part where we specify that public IP is here. We will translate all of these private addresses specified inside of access list 1 into whatever address is configured on the Fast Ethernet 0/0 interface. And the last word in the command, overload, this pretty much tells the router to use ports, which is what you have to use when you're mapping many inside IPs into a few or only one outside IP. Speaking of inside and outside, as already mentioned, we're expected to tell the interfaces whether they're inside or outside, and these are the commands. Hope that was clear for you. If there's any questions, please post them in Q&A, but hopefully the exercise will help. See you there.